problem. We have Batman jumping from one rooftop to another. The second rooftop is told to be 5 meters below the first rooftop, so that will be our Y distance will be 5 meters. Also, the second building is 4.5 meters away from the first building. What we're trying to find in this problem is the initial velocity in the x direction, because we know that it's horizontal, at which Batman would have had to been running to make that jump. So to set up our table, we put in all the normal things. Acceleration in both directions, we know. The initial y direction, or y velocity is 0. We know that Batman is going to fall 5 meters, so our y distance will be negative 5 meters, and we also know that the x distance will be 4.5 meters. What we're trying to find in this problem is the initial x velocity. So this is different than other problems that we have seen before. Before, we've been given the initial velocity and we were trying to find distance. Now it's in reverse, so we're going to have to think through some different ways of doing this problem. So we know that what we want to find is in the x direction. I only see that I know two things in the x direction. I know the distance and the acceleration, but that's not going to be enough for being able to find the initial velocity. Just like always, the only real way to add information to one side is to use the other side to find the time. Still, time is the only thing that is the same for both, always the same for both x and y. So if we don't have enough information in the x direction, I think that our best bet is going to be to use y to find time and then use x to find the initial velocity. Using y to find time, I know that I have to use the second equation because it's the only one that does not require me to have final velocity. So that's what I'm going to do right now. I just messed that all up. Let's try that again. The second equation is that the y distance is equal to the initial y velocity times time plus 1/2 at squared. Okay, now we're good. All right, so now we plug everything in. The y distance is negative 5 meters. Cool, down. Good boy. The y initial velocity is 0 meters per second. We're finding time. The y acceleration, negative 9.8. And this is just the same as it has been in the past. To simplify this down, this first part, because it's multiplied by 0, will just be 0. So we're left with 1/2 of 9.81, which is negative 4.9 meters per second squared, times the time squared. To get t squared on its own, I divide again by 4.9 meters per second squared on both sides. This will cancel. I'll be left with time squared. I know this is going to be close to 1, but not quite. It should be a little bit more than 1. Let's see for sure. 5 divided by 4.9 will be 1.02. Second squared is what will be left here, and then you need to take the square root of both sides to get the final time. Which gives me 1.01 seconds. Cole. Come on, let's go, buddy. This is Cole, everyone. Cool down. That's a good dog. Oh boy, good dog. Okay. Alright, so we found the time. I'm going to plug that in up here. 1.01 seconds for both x and y. Now I have distance, time, and acceleration on the x side. That will be enough to find the initial velocity. Once again, I know you're getting bored of the second equation, but we don't have final velocity. We do know it's going to be the same as the initial, so there might be a few more options here, but I'm still just going to use the second equation because I know it's going to work. we're solving for that initial x velocity. We know the time. This time, 0 is the acceleration in the x direction, so this 1/2 at squared part of the equation, that will all be 0. And we'll be left with 4.5 meters equals the initial x velocity times 1.01 seconds. To get the velocity on its own, I'm going to divide by 1.01 seconds so that it will cancel over here. .5 divided by 1.01 is 4.46 meters per second. So what we found is that in order for Batman to successfully land on this second roof, he would have to run with an initial x velocity of 4.41 meters per second.